Oh, welcome back, everybody. Welcome back to my channel. And this is the design of the sixth class of design of street structures. And we have last class we have seen what are the different types of failures and what are the different how to calculate the shear strength, bearing strength, and and tensile strength of the bolt as well as the plate. How do we calculate we have seen, and how to calculate the net area of the plate in case of staggered bolting, how to do that as per the caudal provisions we have seen. And now we will go into the details how of different types of problems. How do we do the problems regarding the joint connection, design of bolts, and safety of the section? We will see how it is. Here mainly we'll be dealing. Before that, if you are not subscribed, this if you like the channel, please subscribe it, and also press the bell button. And these are the different types of problems we'll be dealing in this chapter. First one will be the finding the strength of the bolt. Next is finding the strength of the joint, efficiency of the joint, design the joint, and check the safety of the joint. Almost all these five cases, it is one or the other way it is the same, but some terminology is different, and understanding the problem it is important. So let us see how do we how do we go forward. Finding the strength of the bolt, as you know it very well. The strength the bolt will be having, especially when you have a general straight load. When you have the direct load, you will be having only bearing as well as shear. So in this case, what you do is you find out when you are asked to find out the strength of the bolt, find bearing strength of the bolt, find shear strength of the bolt, take the least. Take the least. That is what is going to be the strength of the bolt. Whereas in case of strength of the joint, when you say the joint involves the plate also. So in addition to the bearing and shear strength of the bolt, you need to calculate the strength of the plate also. Out of these three, which is the least, that is what is going to be the strength of the joint. Yeah. So only difference between 1 and 2 is here the bolt plus plate will also come. Plate will also come. Whereas here only the bolt will come. Okay. And find next is to find the efficiency of the joint. That you know it very well. Efficiency we have seen the strength of the joint divided by strength of the solid plate. We have seen the last class. Yeah. Another thing is design the joint. This is one of the practical cases which we might deal, face in, in the site. Design the joint actually, because the load will be given and we need to find out how much is the diameter of the rivet, the diameter of the bolt, and how many number of bolts are required. Yeah. And check the safety of the section. This is also a practical case, pure practical case. Check the safety of the section. It is nothing but the section will be given, the load will be given, and the diameter of the rivets and number of rivets will be given. We need to check whether to take that load, whether these rivets are sufficient. This will be mostly in the case of additional. So already one work is done, and you need to add some more load on that. At that time, whether the existing structure is safe or not, existing joint is safe or not. That is what. This is a pure, practical case. So let us go into the problem now. We will see one problem. See, this is a problem of design case. Design problem. The fourth case which I told you, the design. This design category. Yeah. Let me read out the problem. Design the following joint. Design the following joint using ordinary black bolt. Ordinary means it's nothing but a normal bolt actually. To join between two plates of width 200 mm and thickness 10 mm and 18 mm. Because two plates 10 mm and 18 mm plates are it is to be joined. The load coming on the joint is 150 kilonewton. Load coming on the joint is 150 kilonewton. So we need to design a lap joint. We need to design a single cover butt joint, we need to design a double cover butt joint from the data given to you. Okay, use plates made up of Fe410. Means the grade of the plate is Fe410. Okay, and the diameter of the bolt is 16 mm and the bolt grade is 4.6. So this is the question. Two plates, 18 mm and 10 mm to be joined. So let us see what are the given data. Let us write down the data given in the question. Width of the plate is given 200 mm. The plates are 200 mm. Width in the sense it is like this. If the plate is like this it goes. Okay, this width is 200 mm. This is 200 mm. Yeah, that's what is given. And the thickness of the first plate is 10 mm, second plate is 18 mm. This is 18, this is 10. And the load coming on the joint is 150. And FUB, the strength of the bolt, it is given 400 because it is given, the grade is given 4.6. So from this 4 into 100 will give 400. And the diameter of the bolt is 16 mm. Diameter of the hole is 18. As per the code, we know that if it is 16 mm or above, then D plus 2 is the diameter of the hole. So 16 plus 2 is 18. Diameter of the plate, it is given Fe410 grade. So it is going to be 410 megapascal. And another thing is, so okay, let us stop it here now, time being. And this A and B and ASB we need to calculate. What is A and B? Because as I told you, because we have, thread, a bolt will be like this with head, and in that, some area we have thread will be there. This thread area is called A and B. This is A and B. We have seen before. And the shank, this is called shank. Shank area is called ASB. Okay. So that these two we need to calculate. I think A and B is nothing but, as you know, this is nothing but A and B is nothing but it is calculated like this, as you know. We have seen in the last class. It is 0.078, 0.78. It is 0.78 pi d square by 4. Pi d square by 4. This is simply the pi d square by 4. You have seen it before. Okay, so A and B you will get, it is 157, and ANS it is, you will get ASB you will get 201. Okay, so how are we going to apply the, going forward? So the question is, we need to design three types. One is lap joint, other one is single cover butt joint, and the last one is double cover butt. So let us take the first case, lap joint. Lap joint is nothing but like this. So our aim is to design the joint. Meaning is that we need to find out what is the diameter of the bolt and how many number of bolts are required. But diameter of the bolt is given here directly, so we don't need to worry on that. So in our case here it is only we need to find out number of bolts. So how do we do that? We don't know how many numbers are required. So the only question is, we should know one bolt can take how much load. The total load is given 150. So if we could find out one bolt can take how much load, meaning the strength of the bolt, then the total load, which is 150 divided by strength of one bolt, will give you number of bolts. Yeah, that is a easier. That is a way. So you know how to find out the strength of the bolt. You will find out shear strength and bearing strength, and we will take the least one. So shear strength formula is this. We have seen the previously. And bearing strength is this one. So shear strength, so we know all these things. FUB, we know it 400, And n means as you have seen for a lap joint, because this is nothing but number of shear planes intercepting the thread. Okay, so as I told you before, assume in the lap case nn is equal to 1. If it is a lap joint and single cover butt joint, assume that the shear plane comes in the thread, and this will be 0. Okay, and A and B we have seen, and ASB also we have seen. So substituting all together, this is the formula. So you will get 29 kilonewton. Okay, and 29 kilonewton is the shear strength of the plate. I mean bolt. And coming to bearing strength, this is the formula. VDPB is equal to 2.5 kb D into T into Fu divided by gamma mb. So the only thing here it is this kb, as per the code, we have to take the least of all these three. So E is nothing but end distance. So that we can calculate, because normally as per the code E is 1.5 times 1.5 times D0 divided by 3 D0. 1.5 times D0 divided by 3 D0. 3 D0 is already there in the formula. E is nothing but 1.5 D0. So this will give you 0.57, I think. 0.57. Okay. And P, you can take P is nothing but 2.5 times. Normally, as per the code, the minimum pitch is, if it is not given, you take 2.5 times D. 2.5 D is the pitch divided by 3 D0 minus D0 minus 0.25. Okay, so this is also coming 0.67. And this value FUB by FU, FUB is 410, 400, FB is 410, so this is coming 0.9. So out of this 4, 1, 2, 3, 4, the least one is 0.57. Least one is 0.57. So substituting that in the problem, I mean formula, 2.5 into 0.57 into 16 is D, and T is, we have two thickness here. As you can see here, one is 150 10 and other one is 18. So the least one we should take, because least one is going to be the critical, which will be the one which fails first, bear first. Okay, 16 and 10. And FU is nothing but, don't take which, because as I told you before in the previous class, FU, when I say FU, normally it refers the strength of the plate. FU is 410, and the strength of the I mean the tensile strength of the bolt is 400. Sorry, plate is 400, plate is 410 and bolt is 400. So since you are finding out the bearing strength of the bolt, which is the least one you take, because either plate may bear or the bolt may bear. So which is the least, that one you take. So 400 is the least, so that you take. So ultimately you will get 74.78. Okay, so your shear strength is 29 and the bearing strength is 74. So the strength of the bolt, let us say the strength of the bolt, if you say the strength of the bolt, it is the least of bolt is equal to the least of these two, so it is 29 kilonewton. Okay, so one bolt can take only 29. If it is more than 29, it will fail in shear. Okay, so what is the next? So we need to find out how many number of bolts required. So number of bolts is equal to total load. Total load is 150 kilonewton divided by strength of one bolt is 29. So this is equal to approximately 6 numbers will come. So this comes around 6 numbers. Okay, so this is what we can draw, because this is the load coming. Load is applied here. It is 150. Okay, So the thing is, uh, so only six, so three, two rows we can give. Otherwise, 3 into 2 rows, whatever it is. So this is the best way it's going to be. And this distance is called pitch. This is P, and this distance is called G, gauge. Okay, this is your end distance. This also you can take it as end distance. This one, end distance, and this edge distance. So let us take same. So E is, as we have seen previously, E is 1.5 D0. This is coming approximately. It is coming to be approximately. It will come 30, and 2.5 D. It is approximately. It will come 50. Okay. So that we can 30 and 50 you can take. 2.5 into D is 16, so 40 approximately. Yeah, this we can, instead of 50, 40 will be better. 40 we can take. This is 27 comes, so you can take 30 and 40. Yeah. So this is going to be, E is going to be 30. 30. This is also 30, and pitch is going to be 40. Okay. So our main aim is, when you design it, you should tell them how much should be the bearing. This is called overlap. This overlap, how much it is, you should tell. So this is going to be 30 plus 40 plus again 40 plus 30. It is coming 80 plus 60, 140. 140 mm. Yeah. And here it is 30. Total it is 200. It's given in the question. So G is equal, this is 30. This is also 30. And this will be 200 minus 60 will be 140. G will be 140. So that's all. So design of this slab joint is over now. The first case. So you would have understood how to do this. How you are calculating. What is the main part is here only. Find out the strength of single bolt. Since the load is given to you, the number of bolt we need to find out. So total load divided by strength of one bolt. So now coming to the second case. Case number 2 is single cover butt joint. Okay. So single cover butt joint means you will have only one cover plate. It is the thickness of the cover plate is given to you. It is 8 mm. Okay. So its load is 150. Okay. So this is also, it is going to be the same way. Like we need to find out the shear strength, bearing strength, see the strength of the bolt, then total load divided by strength of the plate will give, strength of the single bolt will give you number of bolts. So this is, so this shear strength, when you calculate the shear strength, this is the formula, and FUB is not going to change, it is the same, which is 400. Number of, because here and the previous case, previous slab joint case also, the situation is exactly the same, both cases. Case of shear, because this is a shear plane, it's only one shear plane. Previous also it is only one shear plane. This is, we will assume that it is NN. NN is equal to 1. So same ANB, ASP, everything we have calculated before, nothing is going to change. So here also the case is 29 kilonewton. I think it is 29. Yeah, we have calculated, yeah, 29 kilonewton is the same as previous case. Okay. So shear strength. So let us come to the bearing strength. Bearing strength also, see, is 2.5 into KB. It is, that is also not going to change, because edge distance is 1.5 D0. The least of all these three, all these four we are calculating right now. All these three, it is going to be the same only, because nothing is going to change here actually. So that is 0.57, and diameter of the bolt, it is 16, or which is the diameter? Yeah, 16 into thickness, that is what the only difference it will come here actually. uh, so we can I can write it like this, because in the text it will be space will be, you see here. So it is going to be 2.5 into 0.57 into 16 into thickness. This thickness, because as I told you, we have a three thickness here: 18, 10, and 8. Out of which is the least one? That one we should take. Okay. So this is going to be 8. 8 is the. This is going to be 8. Let us write like this. Sorry. 8 into FU. FU is 400. No change in that. So this is coming to be how much it is? 58 point something, yeah. 72.9. This is 72. Is it? No. It's going to be 58. It's going to be 58.3. Okay. So bearing strength is 58 and the shear strength is 29. So the strength is nothing but the least of these two. Strength of the bolt, as in the case of previous, strength of the bolt is equal to 29 kilonewton, the least one. Okay. So now we need to find out number of bolts is equal to nothing but same as in the case of say 150 divided by 29. It comes around approximately 6, as in the case of previous one. 6 bolts it will come. Yeah. So this is what. So we need to draw the figure. That is very important. So let us draw the figure like this. This is your one plate, and drawing the plan. This is another plate, butt joint, and let us say our plate is this one. I will use, just to see it, no, I will use a small one like this. Okay, let it be. This is the plate. I'll give in different color. Okay. So how many bolts are there? 6 bolts. 6 bolt means one side 6 bolts. Okay, don't give total 6 bolts. Yeah. So one side itself you should give 6 bolts. So this is the one here. 6 bolts means one can give 2, 3, so 1, 2, and 3. Okay, same way here also. Like this. Yeah. So same way we need to calculate the pitch and all these things and all. Okay, this total is 200. Okay, so how much should be the, this one we should calculate. Okay, you can do like this. This is pitch. Previously how much we have taken P. I think this, let's see the previous one. 40. Correct, no? So this is 30. This portion it is 30. Then this is 40. Again 30. here also 30. I think it is going to be, so I can write it is like this, not to have confusion. This distance is, this is 30, this distance is 40, this is again 30, this is again 30, then 40, 30. So total is 30 plus 40, 70, 70 plus 300, 100 plus 100, 200. This is same way here. This one we have seen it is 30. Then this is 40. Okay, before that this is 30. Okay, so total is 200. So 200, this is given as 200 here, because thickness of the, I mean width of the plate is given as 200. Okay, this is 200 together. So 200 minus 30, 230 plus 30, 60. So 140. So this will be, this can be 70 and 70. Okay. So this is what we need to give. Now coming to the final part, it is going to be what is that? Double cover butt joint it is. So the third part is case 3. It is case 3. Double cover butt joint. And the cover plate thickness is 8 mm, is it? 8 mm. Cover plate thickness is 8 mm. So it is going to be like this. Double cover butt joint means we will have, these are two places, top and bottom. This is one. I will make it much bigger. This is one plate, and another plate is going to be here, but the thickness is less, 18 and 10 it is, this 10. Okay, and you will have your cover plate here, one cover plate here, and you have another cover plate at the bottom. Here we don't need to provide any cover plate here, even though thickness is less. In this case, what happens is only one, one cover plate only comes here. The previous case I am telling, here you have only one cover plate. Okay, so it is not a problem, because we can, as I have shown here, you don't need to give a cover plate, I mean packing plate here actually. Okay, I think in fact this is not required, it's already drawn there, packing plate required. But here what happens is, this portion, it is going to be a vacant. This area is going to be void, so we need to provide a packing plate here. So this is 8 mm, this is 10 mm, this is 18 mm, this is 8 mm, this is 8 mm. So this area, it is going to be a cover plate, I mean packing plate should be provided. What will be the thickness? 18 minus 10, this will be 8. It will be the thickness. Okay, and as usual your bolt will come here, one or two, whatever it is, bolt will come here, bolt will come here. Okay, so that's all. So here also same case, we need to provide the shear strength of the plate, BDSB. Shear strength of the plate we need to find, shear strength of the bolt we need to find out. So we need to just let us copy the formula as it is. This is the formula. Yeah, and let us copy other formula also. Bearing strength of the plate. Sorry. Here, so let us write down everything. So as I have been telling you before, when you have a double cover butt joint, so NN you should take one, NS also you should take one. Okay, there is only difference coming here actually. So let us find out everything. So this is 400 into 1 into 150. ANB is 157 plus NS is equal to 1, and this is 20. How much it is? ASB, area of the shank area, somewhere here 201. 201. Okay, and all divided by root 3 into 1 gamma MB 1.25. So this is coming to be VDSP. It is coming to be 52.21 kilonewton. So note down the point here. It is actually here the plates are in, I mean, bolt in single double shear actually. This is one shear plane, this is one shear plane. That is why ANB and ASB, I mean NN and NS came. So previous case you got only 29. Okay, now it has been increased. So since it is a butt joint, when there is a more than two planes are there, two shear planes, so automatically your strength will increase, because if you fail here also, the joint will not be separated. Both has to be failed. This place and this place it has to be broken. Then only the joint will be separated. Okay, so that you keep in mind. And coming to this one VDPB, this formula, bearing strength of the plate. So we will also here substitute everything. So let us see how it is. So 2.5 into KB also it is not going to change, 0.57. D is 16, and T the least one, meaning you have here also 8 here, the least one out of this all this least, see because this is 8 mm, this is 8 mm. So cover plate thickness you add it, so 8 plus 8 it is 16. So you have 16, 18 and 10. This one don't consider, this packing plate please don't consider, because it will not take any load. So 8 cover plate thickness both you add it, 18 plus 18 16. Okay, so compare this with 18, 16, this is both together 16, this is 18 and this is 10, out of which the least one is 10. Okay, so that one you please take. As I think we have explained it in the previous class how we want to take 8, why we are not taking 8 and why you are taking 10. So you should, because the load will be half here actually, because it is going to be like this, one placed here, one place here and one place here. Okay, here it is 150, this is 75 and 75 the load, here it is 75 75. So this is 8 mm, this is 8 mm, this is 10 mm. Okay, so the least one is 8 plus 8 is 16 for 150 load. So the possible chances here it is the more critical, so that is why it is coming. So 16 into 10, okay, into 400. all divided by 1.25. So how much it is coming? So this is coming to be for the, I think 74 point something, 74 point something, I'm not sure. Okay, anyhow it is more than that, 74.1. So in this also, and one more thing I would like to highlight here, it is here, if you remember, okay, before I'll come to this, before that, uh, here, because you are using a packing plate. So in the previous classes we have discussed, when you are using a packing plate, if you are using a packing plate, thickness of the packing plate is greater than 6 mm. As per the code, thickness of the packing plate is more than 6 mm. You should use a reduction factor called beta PKP. You should use a reduction factor called beta PK packing plate, PKP, sorry, PKG. Okay, whatever it is. Okay, so how do you calculate the reduction factor? The formula for that one is the reduction factor formula, vacuum plate formula, reduction factor, it is beta. I already explained to you why we are taking that beta PKG, PKG vacuum plate. This is equal to 1 minus 0.0125 thickness of the packing plate. Okay, in our case it is 1 minus 0.0125 into what is thickness of the vacuum plate? It's 8 mm. This is the one, 8 mm into 8. So this is equal to, it's coming 0.9. Okay, so you should multiply this with this value. I think this reduction factor, no, this one value, you should multiply with the 0.9. Okay, so this should be multiplied with the 0.9. After multiplying with 0.9 only, you will get 52.21. Okay, so we are fine. So important, from the previous problem, the only difference here it is we should multiply with the this one, reduction factor for packing plate, beta PKG, right? So that one we should multiply only with the shear, because this packing plate, when you pull the load here, this will create a bending moment. When you pull it like this, the bolt will try to bend like this. Okay, but our assumption is that the bending moment, the bending stress in the bolt we don't take. So to take care of that one, we are multiplying with this reduction factor. So what is the least to strength? So the strength is equal to, out of these two, the least one is 52 and 74. The least one is 52 kilonewton, 52.2 kilonewton. Okay, no problem. 0.2, nothing is going to happen. So from this we need to find out the strength of the bolt. I mean strength of the number of bolt. Number of bolts is equal to 150 is the total load divided by 52.2. So it comes around 4, approximately 4 numbers. Okay, so as we discussed before, I think same problem, same figure I can, okay, let it be. Draw the figure like this. One plate here, another plate here, then give different color. Here, this one. So this is going to be we will have total we have 4, so we will give here 1 here. I mean, it is better to give because the total, it is not like the total number is 4, so we need to give each side 4 balls. So let us see, we have to arrange it like this. One we will be giving here, another one here, okay, another one here, and another one here. Same way the other side also. So we will have one here, one here, and here, okay. And as we discussed before, you please you decide, you find out this edge distance, this, and decide how much is the total. I think that's the end of this problem. I think, hope you all understood it. Thank you very much. We will continue next class. Thank you.